Good morning, dear students. Today I will be discussing a question from multiple integrals, second exercise. So, in that, now we'll be discussing the solution of question 63. So, our question is evaluate integral of f of xy is equal to y minus 2x square over the region bounded by the square mod x plus mod y is equal to 1. So we are asked to find the integral of f of xy over a region, square region. Mod x plus mod y is equal to 1. So here we are asked to find double integral of f of xy dx dy, or you can find double integral f of xy dy dx. Whichever you find convenient, you can find that. Now here, first we are going to discuss about the region. Mod x plus mod y is equal to 1. We had to first identify what our region is. Only then through that we can find the limits of x and y. So our region is mod x plus mod y is equal to 1. We are very much familiar with mod x and mod y. But mod x plus mod y equal to 1 is quite a new topic, I guess. It's quite a new concept. So we know mod x means plus x and minus x. Mod y means plus y and minus y. So mod x plus mod y is equal to 1 means mod x plus mod y equal to y means it will take all the plus and minus values of x and y. It will consider both all the positive and negative values of x and y. So mod x plus mod y equal to 1 can be written as x plus y is equal to 1. Here both x and y are positive. X plus y equal to 1. Minus x plus y is equal to 1. Minus x minus y equal to 1. X minus y is equal to 1. So all these four equations together we can write as mod x plus mod y is equal to 1. Now our region is bounded by these four lines. Now we can plot these equations. So we are familiar with plotting or sketching equations. So first we'll consider the first equation x plus y equal to 1. So in that we are familiar how we'll be sketching it. Put x equal to 0, you will get y equal to 1. Similarly, put y equal to 0, you'll be getting x equal to 1. So the line joining these 2 points is our x plus y is equal to 1. Similarly, you'll be putting x equal to 0 in second equation. Then y is equal to 1. So this point. Now y equal to 0, you get x equal to minus 1. So you get the line joining these two points. Now another minus x minus y equal to 1. You put x equal to 0, y equal to minus 1. This point, and y equal to 0 will get x is equal to minus 1. So and y, if you put x equal to 0, y equal to minus 1. So you get these 2 points. So the line joining these 2 points is our line minus x minus y is equal to 1. Similarly, you'll be getting x minus y is equal to 1. You put x equal to 0, you'll get y is equal to minus 1. X equal to 0 minus 1, and you put y equal to 0, you'll be getting x is equal to 1. So line joining these 2 points, that is x minus y is equal to 1. So our region is bounded by these four equations. So this square is our region. This is our region. Now we have to find double integral, the value of double integral f of x. Either you will be finding double integral f of x dx dy, or you have to find dy dx. As per your convenience, you can do it. So I am going to do double integral f of x dx f of xy dx dy. So when we are going to find double integral f of x dx dy, here we know that we have to know the limits of x and y. So to know the limits of x and y, in this case we'll be considering horizontal cross-section method. We have done a lot of questions in horizontal cross-section method and vertical cross-section method. So here we'll be doing horizontal cross-section method. So suppose if some students are taking double integral f of xy dy dx. In that case, they have to use the method of vertical cross-section method. So now we are going to use the horizontal cross-section method to find the limits of x and y. So basically in a horizontal cross-section method, first we draw a horizontal line passing through this region anywhere, and we see that as we can shift this line from this point to this point to cover this region. But we can see that as we shift this line from this point to this point, our boundaries are same. But once we shift this line above the origin, our boundaries of this line changes. So in such cases, we'll be considering two horizontal lines L1 and L2. So here we are going to consider two horizontal line L1 and L2. Now L1 will be considering in the lower triangular region and L2 we are considering in the upper triangular region, because we have already discussed such cases. Because here we can say in the lower triangular region and we can shift L1 from this point to this point and our boundary remains the same. And in L2 case, we can see that we can shift from this point to this point and our boundary is still the same. So we'll be considering L1 in the lower triangular and L2 in the upper triangular. Okay. Now first we'll be considering L1. So by closely observing L1, now we'll be finding the limits of x and y. So we can see that this line L1 touches this lower region, touches the region at this point. And at this point, what is the value of x? At this point, the value of x is, we know that it is a point of this equation. So from here, the value of x is -1 minus y. And as this L1 passes through the region, it touches this line at this point. So at this point, the value of x is 1 plus y. So you'll get the limit of x from -1 minus y to 1 plus y. Now we know that this line L1 can be shifted from this point to this point to cover the lower region. So at this point the value of y is -1. At this point the value of y is 0. This is origin. So the value of y is from -1 to 0. Similarly, we can now look at line L2. We observe this line L2 which passes through the region. We can see that at this point the value of x is -1. The value of x is -1 plus y. And at this point the value of x is 1 minus y. So the limit of x is from -1 plus y to 1 minus y. And we can see that we can shift this line from this point to this point to cover this region, upper triangle region. So the limit of y at this point is, the value of y at this point is 0, the value of y at this point is 1. So we can see that the value of y is from, limit of y is from 0 to 1. So we have now easily found the value of x and y in both the cases, in L1 and L2. So now we are going to do our integration part. We have to find double integral f of xy dx dy. This is equal to double integral f of xy, double integral L1 f of xy dx dy plus double integral L2 f of xy dx dy. Now separately you will be finding these two and you will be substituting in this. So first I am going to consider in case of double integral L1 f of x dx dy. So here we have already found the limits of L1. We'll be putting the limits. We know what is f of xy. F of xy is a function y minus 2 x square. The limit of x is from minus 1 minus y to 1 plus y. Limit of y is from minus 1 to 0. Now we'll be doing our double integration, ordinary double integration. Integral minus 1 to 0. We know that the limit of first we'll be integrating the interior. First we'll be integrating this interior integral. So here we have to integrate with respect to x first and then with respect to y. So when you integrate with respect to x, you will consider y as a constant and you will be doing the integration, and you are having the limit from minus 1 minus y to 1 plus y. You will be putting the upper limit. You will substitute the upper limit minus lower limit. You will simplify it. Then after simplifying, you can simplify it, and after simplifying, then you have to integrate with respect to y. So after this step, you will be integrating with respect to y. You'll here the limit is from minus 1 to 0. You will put the upper limit minus lower limit. So you'll be getting the simplification. You'll get minus 4 by 3. Okay. Now this is our first part, double integral over L1. Now we'll be doing a second value, that is double integral over L2 f of xy dx dy. So in case of L2, we have found the limits of x and y. The limit of x is from minus 1 plus y to 1 minus y. The limit of y is from 0 to 1. So you will be putting all these values. The value of x is y minus 2x square dx dy. So first we will be integrating with respect to x. So when you integrate with respect to x, you will be considering y as a constant. So you'll be doing the integration. These are basic integrations, so you can do it. Then you'll be doing. Now we are having the upper limit and lower limit. That is minus 1 plus y and 1 minus y. You'll put the upper limit minus lower limit. You'll simplify it to the most. Simplifying it, so first put the upper limit and lower limit and simplify it in this form. Okay, after simplifying to this form, now you have to integrate with respect to y. So once you integrate with respect to y, again you will be simplifying it, integrate it, simplify it, then you are having the limit of y from 0 to 1. So you will be putting the upper limit minus lower limit here. So you will be getting 2 by 3. So in the first case we got minus 4 by 3. From the second case we got 2 by 3. So finally our adding for L1 and L2 we get the value is minus 2 by 3. So our next question is question number 65. Evaluate the following integral. So we have to evaluate this integral. Integral 0 to 1, integral 2y to 2, 4 cos x square dx dy. So we have to integrate this. Okay. So we already know that when we are having a double integral, we can directly integrate it. Here we can see that if we are having an double integral of this form, first you have to integrate with respect to x, then with respect to y. But here we can see that here first we have to integrate it with respect to x, then with respect to y. So when you integrate with respect to x, we see that there is integral cos x square dx. So whenever you are having only cos x square as integrand and you have to integrate with respect to x, we know that this is not an easy task for you to integrate cos x square dx. We can integrate cos x, sin x and all, but alone if a function stays as cos x square, it is not easy to integrate it. So, but we can think that we are learning double integral, so we can think about um, changing the order of integration. Suppose if it is dy dx, just think dy dx. In that case, this cos x square becomes a constant. If you have to integrate it, this is dy, then this cos x square becomes a constant. We can take that outside and we can integrate it much easier way. So now we can think of changing the order of integration in that case. So to change the order of integration, first we have to know the area, the region properly. So here to know the region, we can know that first here it is x. So the limit of x is from 2y to 2. 2y less than or equal to x less than or equal to, and here it is dy, so the limit of y is from 0 to 1, 0 less than or equal to y less than or equal to 1. So this is our region. Now we have to sketch this region. So sketching also we have done a lot of times. First we are doing this boundary 2x 2y equal to x. So how to plot 2y equal to x? First you will be giving x is equal to 0. Put x is equal to 0, you will get the value of y is equal to half. If you put x is equal to 0, you will get some value x equal to, sorry, if you put x equal to 0, you will get y is equal to 0. Okay. If you put x equal to 0, you get y equal to 0. Similarly, if you put x equal to 2, you get y equal to 1. So this is the line. Joining these 2 points, we get 2y equal to x. Similarly, another boundary is x is equal to 2. X equal to 2 means if this is 1, this is 2. Line passing through the point x is equal to 2. This line. Now another is y equal to 0. Y equal to 0 means our x-axis. Then y is equal to 1. So this region. So the region bounded by all these boundary is this. So this is our region. So we have to integrate under this region. Okay. Now we have to change the order of integration here. So changing, we know here it is dx dy. We have to change to dy dx. Dy dx means we'll be using vertical cross section method. So to get the limits for double integral dy dx, you have to use a vertical cross section method. So in case of vertical cross section method, what can you say about vertical cross section method? You have to draw a vertical line parallel to the y-axis, and you will be observing this line and you will be writing out the limits of x and y. So we can see that this line touches this region first at this point. So at this point, what is the limit of y? At this point, what is the value of y? This is x-axis. So at this point, the limit of y is 0. At this point, the limit of x is y is 0. Now, as this line passes through the region, it touches the boundary at this point. At this point, what can I say about the limit value of y? Now, we can say that this equation is 2y is equal to x. So, from that, we can get the value of y. That is, y is equal to x by 2. So, we get the limit of y as 0 to x by 2. Now this line covers this region when you shift from this point to this point. So you have to see at this point what is the value of x. It is an origin, so it is certainly x is equal to 0. And when you shift from this point to this point, at this point what is the value of x? X is equal to 2. So we get the limits of x and y as x equal to 0 to x equal to 2 and y equal to 0 to y equal to x by 2. So these are the limits of x and y. Now we'll be substituting it. So we will be getting double integral. The limit of x is from 0 to 2. Limit of y is from 0 to x by 2, 4 cos x square. Okay. Now, we can see that integral 0 to 2. First, we have to integrate with respect to y. So here, in that case, this is a constant throughout. 4 cos x square is a constant, and the integral dy is y. You will be putting the upper limit minus lower limit, so you will be getting all this integral 0 to 2 2x cos x square dx. Now here we can see that how will you integrate this? By the method of substitution. We know that if you put x square equal to t, 2x dx equal to dt. Okay, so you have to put x square is equal to t. Put x square equal to t, so 2x dx equal to dt. So substitute integral cos t dt. What is integral cos t dt? Sin t, 0 to t. Now what is the value of t? T is x square. So sin x square, limit from 0 to 2. You will be putting the upper limit minus lower limit. So sin 2 square minus sin 0, that is sin 4 minus 0. So you get sin 4. Answer as sin 4. So next we are going to solve question number 67. Find the volume of the solid whose base is the region in the xy plane that is bounded by the parabola y is equal to 4 minus x square and the line y equal to 3x, while the top of the solid is bounded by the plane z is equal to x plus 4. So we have to find the volume of a solid. So volume of the solid, usually when a question is asked, volume of a solid means you will be given an upper region, upper bound and a lower bound. Upper bound or lower bound given ആയിരിക്കും. So using that you will be finding volume of a solid. Between we will be having a solid will be generated between these two, upper bound and lower bound, and we have to find the volume of a solid whose upper bound is f of xy and lower bound is a region given in the question. Okay, so first you have to identify function f of xy and a region. So if you know the function f of xy, that is the upper bound, and the region, that is the lower bound, you have to find the volume between these two, upper bound and lower bound, that we have already discussed the formula as volume. We have discussed as V is equal to double integral f of xy dx dy or dy dx. According to your convenience, you can find both the values will be same. So here I am going to find V is equal to volume formula is V is equal to double integral f of xy dy dx. Okay. So first we have to identify f of xy and our region R. So if we know f of xy and region R, then we can find the volume of the solid bounded by f of xy and R. So from the question, we know that the question is, from the question we know that the top of the solid is bounded by z is equal to x plus 4. Z is equal to x plus 4 means the value of f of xy is x plus 4. And we also must know, so f of xy is equal to x plus 4. And we also know the region. The region is, the base is the region in the xy plane that is bounded by the parabola y equal to 4 minus x square and the line y is equal to 3x. So our region is y is equal to 4 minus x square bounded by this parabola and the line y equal to 3x. Okay, so first we are going to sketch our region properly. Now we know that our region is bounded by parabola y equal to 4 minus x square and y equal to 3x. So first we can draw this y equal to this line y equal to 3x. It is very easy. So first we can do that. How will you do? Put x is equal to 0. When you put x equal to 0, you will get y equal to 0. So one point is 0, 0 point. Another point we can plot in the x is equal to 1. If you get x is equal to 1, the value of y is 3. So you can get this, or you can take any values. So when you take any values, we can draw a line passing through these lines, and we get our equation y is equal to 3x. Okay. Now we are going to sketch y is equal to 4 minus x square. So this is very interesting. We have been doing various parabolas. So we know y equal to 4 minus x square. So we have been doing a lot of other parabolas. So simply let me sketch here. Like we have done certain cases y square equal to 4x. A parabola y square equal to 4x is of this type. Y square equal to minus 4x. A parabola y square equal to minus 4x is of this type. Okay. So in the same way, a parabola x square equal to 4ay. X square equal to 4ay is of this type, and a parabola x square equal to minus 4ay is of this type. Okay. So here we will be having a parabola of this form, x square equal to minus 4ay, because we can see that from here, if we are taking x square, the value of x square is equal to, we get 4 minus y. So the coefficient of y is a negative value, right? The coefficient of y is a negative value, so you'll be getting a parabola of this form. So this is the way of our parabola. It should look like this. Y equal to 4 minus x square should look like this form. Okay. So now we can see that we know that our parabola looks like this. Now, if a parabola is drawn like this, it touches the x-axis, y-axis, and you have to see at what points this parabola touches x-axis and y-axis. ഈ പാരാബോള വൈ ആക്സിസിനെ ടച്ച് ചെയ്യുന്ന ഏത് പോയിന്റിലാന്ന് എങ്ങനെ പറയാൻ പറ്റും? യു വിൽ ഗിവ് എക്സ് ഇസ് ഈക്വൽ ടു 0. അപ്പൊ ഈ ഇക്വേഷൻ്റെ അകത്ത് വൈ ഇൻ ദിസ് ഇക്വേഷൻ വൈ ഇസ് ഈക്വൽ ടു 4 മൈനസ് എക്സ് സ്ക്വയർ. ഈ ഇക്വേഷൻ്റെ അകത്ത് വൈക്ക് എക്സിന് 0 കൊടുക്കുമ്പോൾ വാട്ട് ഈസ് ദ വാല്യൂ ഓഫ് വൈ? ഇഫ് യു പുട്ട് എക്സ് ഈക്വൽ ടു 0 ഇൻ ദിസ് ഇക്വേഷൻ, യു ഗെറ്റ് വൈ ഇസ് ഈക്വൽ ടു 4. ഓക്കെ, വൈ ഈക്വൽ ടു 4 എന്ന് കിട്ടും. അപ്പോൾ അതായത് ഈ പാരാബോള വൈ ആക്സിസിനെ ടച്ച് ചെയ്യുന്ന പോയിന്റ് എന്ന് പറയുന്നത് 0,4 ആണ്. ഓക്കെ, ഇനി ഈ പാരാബോള എക്സ് ആക്സിസിനെ ഏത് പോയിന്റ്സിലാണ് ടച്ച് ചെയ്യുന്നതെന്ന് അറിയാനായിട്ട് എന്ത് ചെയ്യും? എക്സ് ആക്സിസിലെ പോയിന്റ്സ് എന്ന് പറയുമ്പോൾ വൈയുടെ വാല്യൂ 0 ആയിരിക്കും. യു വിൽ പുട്ട് വൈ ഈക്വൽ ടു 0. വൈക്ക് 0 കൊടുക്കുമ്പോൾ ഇവിടുന്ന് എക്സിന്റെ വാല്യൂ എന്താ വരുന്നത്? എക്സ് സ്ക്വയർ ഇസ് ഈക്വൽ ടു 4 എന്ന് വരും. എക്സ് സ്ക്വയർ ഈക്വൽ ടു 4 എന്ന് പറയുമ്പോൾ എക്സിന് 2 വാല്യൂസ് ഉണ്ട്, +2 ആൻഡ് -2. സോ ഒരു പോയിന്റ് എടുക്കുക, +2 എടുക്കുകയാണെങ്കിൽ ദ വാല്യൂ ഇസ് +2, 0. -2 എടുക്കുകയാണെങ്കിൽ -2, 0. സോ ഈ 2 പോയിന്റ്സിലാണ് എക്സ് ആക്സിസിനെ ഈ പാരാബോള ടച്ച് ചെയ്യുന്നത്. അതുപോലെ വൈ ആക്സിസിനെ ടച്ച് ചെയ്യുന്ന പോയിന്റ് 0,4. സോ ഈ 3 പോയിന്റ്സിൽ കൂടും പാസ് ചെയ്യുന്ന പാരാബോള ആയിരിക്കും അവർ ഗിവൻ പാരാബോള. ഓക്കെ, ഇതിനെ അങ്ങ് നമ്മൾ സ്ട്രെച്ച് ചെയ്ത് എഴുതുക. ഈ പാരാബോള ഇങ്ങനെ അങ്ങ് ഡ്രോ ചെയ്യുക. ഇനി ഈ ലൈൻ ഇതുപോലെ സ്ട്രെച്ച് ചെയ്യുമ്പോൾ ഏതെങ്കിലും ഒരു പോയിന്റിൽ ഇവിടെ വന്ന് മീറ്റ് ചെയ്യും. ഓക്കെ, സോ ഞാൻ ഓൾറെഡി പറഞ്ഞു, റീജിയൻസ് പ്രോപ്പറായിട്ട് നമ്മൾ ഡ്രോ ചെയ്യുമ്പം റീജിയൻ ഈ മീറ്റ് ചെയ്യുന്ന പോയിന്റ്സ് ഒക്കെ നമ്മൾ ഐഡന്റിഫൈ ചെയ്ത് വെക്കണം എപ്പോഴും. അപ്പോൾ ഇവിടെ ആണെങ്കിൽ നമുക്ക് അറിയാൻ പറ്റും. ഹൗ വിൽ യു പ്ലോട്ട് ദിസ്? ഈ പോയിന്റിൽ ഈ പാരാബോള ഇതിന് ടച്ച് ചെയ്യുന്നത് എങ്ങനെ അറിയാം? ഈ രണ്ട് ഇക്വേഷനോട് സോൾവ് ചെയ്താൽ കിട്ടും. ഓക്കെ, y ഈക്വൽ ടു 3x-ഉം y ഈക്വൽ ടു 4 മൈനസ് എക്സ് സ്ക്വയറും കൂടെ സോൾവ് ചെയ്യുമ്പോൾ നമുക്ക് ഈ പോയിന്റ് കിട്ടും, 1,3 എന്നുള്ള പോയിന്റ്. അത് നിങ്ങളെല്ലാവരും ഹോംവർക്ക് ആയിട്ട് ചെയ്ത് നോക്കുക. ഓക്കെ. അതുപോലെ തന്നെ അപ്പം നമുക്കിവിടെ ആക്ച്വലി വി ആർ ഗെറ്റിംഗ് ടു വാല്യൂസ്. നമ്മൾ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ എക്സിന് 2 പോയിന്റ്സ് കിട്ടും, വൈക്കും 2 പോയിന്റ്സ് കിട്ടും. സോ വി നോ ദാറ്റ് 2 പോയിന്റിലാണ് ഈ ലൈനും ഈ കർവും കൂടെ ടച്ച് ചെയ്യുന്നത്. സോ ഇത് ആസ് എ ഹോംവർക്ക് യു ക്യാൻ സി. ഫസ്റ്റ് പുട്ട് എക്സ് ഈസ് ഈക്വൽ ടു 1 എന്നോ ഏതെങ്കിലും ഒരു പോയിന്റ് ചെയ്ത് നോക്കിയാൽ നമുക്കറിയാം ഈ പോയിന്റ്സ് കറക്റ്റ് ആണ്. ഇത് രണ്ടും കൊണ്ട് സോൾവ് ചെയ്ത് നോക്കുക. ട്രൈ സോൾവിങ് ദിസ് ഇക്വേഷൻ y equal to 4 minus x square and y equal to 3x. By solving these two, you'll be getting the points of intersection of these two. You will be getting 2 points. So from 2 points of x, you will be getting 2 points of y. So you'll be getting these 2 points. Okay. So do this as a homework. Okay. Now, അപ്പോൾ ഇതാണ് നമ്മുടെ region. So this is our region bounded by the line y equal to 3x and the parabola y equal to 4 minus x square. So now we have to find the limits of x and y by using these two. By using this region, now we have to find the limits of x and y. X ന്റെയും y യുടെ ലിമിറ്റ്സ് ഫൈൻഡ് ചെയ്യാനായിട്ട് എന്ത് ചെയ്യണം? You can either use horizontal cross section method or vertical cross section method. Okay, so here I am going to find double integral dy dx. Dy dx എന്ന് പറയുമ്പോൾ we will be using vertical cross section method. You can do according to your convenience. Okay, so vertical cross section method എന്ന് പറഞ്ഞാൽ എന്താ? You will be considering a line passing through this region, vertical line passing through this region. So ഈ ലൈനിനെ ഒബ്സർവ് ചെയ്തിട്ട് എക്സിൻ്റെയും വൈയുടെയും വാല്യൂസ് ലിമിറ്റ്സ് നമ്മൾ പ്രോപ്പറായിട്ട് ഫൈൻഡ് ചെയ്യുക. So we'll be observing this line. So we know that this is our origin. Originന്റെ ഇങ്ങോട്ട് പോകുമ്പോൾ എല്ലാം നെഗറ്റീവ് വാല്യൂസ് ആണ്, ഇങ്ങോട്ട് പോകുമ്പോൾ പോസിറ്റീവ് വാല്യൂസ്. So we can see that this line touches. എപ്പോഴും നമ്മൾ whenever you are considering vertical cross section, we always will will count from the bottom. Okay, horizontal cross section we will count from the left side. So we see that the line enters this region at this point. So this point, what is the value of so this is the vertical cross section. So first we'll be finding the value of y. So at this point, what is the value of y? This is equation of the line. What is the line? Y equal to 3x. So at this point, the value of y is equal to 3x. And as this line passes through this region, it touches at this point, and this point, the value of y is 4 minus x square. So the limit of y is from 3x to y equal to x square. Okay. Similarly, we can see that this line covers this whole region when we shift this line from this point to this point. So this point, what is the value? At this point, what is the value of x? It is, at this point, what is the value of x? We will be shifting. So at this point, we can, so from this point to this. Okay. So we can see that this is -2 and -4 means further so our limit of y is from x is from this point, right, at somewhere this point to this point. So it is from -4 to this point. This point എന്ന് വെച്ചാൽ എന്താണ്? 1. So the limit of x is from -4 to 1. So now we get the limits of x and y. You'll be substituting it and integrating it. Okay. So we get v is equal to integral -4 to 1 integral 3x to 4 minus x square x plus 4, that is our function f of xy dy dx. So now we are going to first integrate with respect to y. So when you integrate with respect to y, you'll consider x as constant. You integrate it, you get in this form. There is upper limit 4 minus x square, lower limit 3x. So So now in the next step, we will be substituting upper limit minus lower limit. You will simplify it. Simplifying it, you will be getting in this form. Okay. So after this, now you have to integrate with respect to x. So integrating, we get this form. There is upper limit 1 and lower limit minus 4. You will be giving substitution upper limit minus lower limit. So upper limit minus lower limit. So you will be getting, when you substitute it, you get 625 by 12.